So next group is the 22. Siddesh, if you can share your screen.
Okay, so good morning to one and all present here. I would first of all like to thank all the members for giving me this opportunity to attend the conference. Our topic for the paper presentation is review of welding defects and non-destructive testing method in welding of 316 stainless steel and 16 MnCr5. The paper is presented by four members, Siddesh Jagdankar, Paresh Barge, Akash Dadge and Karan Lanjewar, studying in PCET's NMIT under the guidance of Professor Jeevan Patil. So, introduction. One of the most difficult confronting modern manufacture is the joining of incompatible material. These similar metal joining technologies are used in a variety of industries, including automobile, microelectronics, medical devices, aircraft, and microsystems. The ability to employ multiple metal and alloy is a product gives the designer and producing engineer more options, and it typically leads to technical and cost advantage over components made of single material. So next is problem statement. Arc welding, resistance welding, friction welding, and laser beam welding are just a few of the welding technologies utilized in production. We have different method of welding, but no comparison analysis of the welding process has been done. Objective. The primary goal of this research is to investigate the various types of welding techniques that have evolved in their limits. Various destructive and non-destructive testing procedures are available. We have select the appropriate kind of welding necessary for welding processes by analyzing all the perspective of welding presented in the text. In this paper, we came across a variety of welding procedures. We learn about the several sorts of welding defects that might develop throughout the welding process. We also learn about the various forms of testing that are required to detect weld faults. But there is one limitation that research is done only for steel metal. Content of paper. We have almost covered each and every form of welding defects and its testing method. So in that first one is abstract. Stainless steel meet all of the following design characteristics among the numerous materials that demonstrate high strength at increased temperature, corrosion resistant toughness, and cryogenic temperature. Stainless steel is used in wide range of industrial, commercial, including several circumstances in the chemical process industries and more delicate conditions in pharmaceutical and food industries. Porosity, blowholes, undercut, weld crack, incomplete fusion, slag inclusion, incomplete penetration, spatter, and all other faults are common throughout the welding. At the same time, the weld quality can be evaluated. Introduction. Stainless steel are iron or stainless steel are iron alloy with a minimum chromium content of 10.5%, with or without the addition of other alloying elements such as manganese, nickel, silicon, niobium, boron, aluminum, cobalt, and so on. The addition of chromium improves the steel corrosion resistance by forming a passive film of chromium oxide, which is why most stainless steel have higher chromium content. Third is classification of stainless steel. Steel can be classified upon various criteria, but we are going to look upon four basic types of steel that are austenite stainless steel, ferritic, martensic, and duplex stainless steel. In general, martensic and ferrite stainless steel are nickel-free, whereas austenite steel require nickel and chromium as alloying elements. The alloying metal nickel and chromium are used in appropriate amount in duplex stainless steel to achieve a various structure that is a combination of austenite and ferrite stainless steel. Now we are going to see different types of welding that are already familiar in our mechanical syllabus, that are shielded metal arc welding, gas tungsten arc welding, submerged welding, plasma arc welding, electron beam welding, laser beam welding. Different forms of welding flaws are described in depth throughout the paper along with their causes. Some of the welding defects are mentioned such as porosity and blowhole, undercut, weld crack, incomplete fusion, slag inclusion, incomplete penetration, scatter distortion, hot tear. Precaution to be taken while welding. The quality of weld is determined by material to be welded and the electrodes used, which must meet the criteria and regulation. Proper joint design selection is essential for a good and robust weld, and slag removal should be done effectively and quickly. Proper bead formation is required to avoid poor penetration and formation of
तुझ्या हायवेचे प्राइसेस किती आहे एकाच्या याला मग ते पण तळेगावच आहे ना
moisture
ठीक आहे जा पडेल ड चालत जा
moisture so cleaning the base metal to remove dirt, dust, grease, varnish, oil, and other contaminants is required to avoid contamination, as the bulk of foregoing materials are convenient source of carbon during welding process. Low current causes electrode sticking, slag interference, and heavy spatter. Proper current level results in acceptable quality joints. Because overly high current value causes crack, distortion, undercutting, and corrosion as a result of chromium loss. The best amperage should be chosen once again. So after that we have inspection of welding joints. In it we will see there are different types of inspection done in the welding joints. This paper discusses many types of destructive and non-destructive welding joint inspection. It also incorporates the most up-to-date technologies for joint inspection. Destructive testing includes chemical analysis, tensile test, impact test, and bend test. And non-destructive testing includes magnetic test, dye penetration test, ultrasonic test, and radiographic test. There are many more, but these are the few I would like to. Then I would like to conclude.
Siddesh, if you can conclude, okay.
Yes, sir. Stainless steel are cost effective to fabricate and have excellent strength and corrosion resistance. Stainless steel is used in a wide range of industrial, commercial, and applications. Food. The paper goes over the classification of steel, the various welding types of this steel, and the various welding processes of the stainless steel. The extensive literature has provided an acceptance comparison of the subject matter of stainless steel welding, which will be further work on welding joints analysis using different welding processes of stainless steel, 316 stainless steel, and 16MnCr5. Then next is a literature view. We have studied many papers, but I would like to mention few. In first paper, we are able to detect accuracy bead dimension for welding purposes to avoid welding defects using laser and convolution neural network technique. In the second paper, we got to learn inspection of welding boundaries and porosity by optical coherence tomography. In third paper, we used gray box inspection distribution and Poisson mating method to quickly and accurately calculate the shape of the keyhole. So thank you one and all being present here and for your patience listening.
Okay, thank you, Siddesh.